Okay, now let's get started with this data set. Okay, with this data set. Now, actually, let's look into the data set directly. Okay. If you go to your RStudio, right? Um, you actually can see that the RMD file and as well as the HTML. So open the HTML first, right? Then open the RMD here. Now again, in front of every notebook there is a code chunk. Usually the first code chunk is like you just run through it. It's just do some preparation for you, right? Okay. So and so you don't need to modify anything in this code chunk. That's what I say here, right? Do not modify. Okay, just run through it. And then the second code chunk is to read in the data, right? And because the data is placed in the data folder here, right? So before anything, you need to set this directory as the working directory, okay? Set this directory as the working directory, then you can read in the data, right? Okay. So after you read in the data, you can see that I name the data as D, right? Actually, you can choose whatever name that fit your needs. But usually when we do data analysis, especially for beginner, I would suggest you use a very short name for the major data frame. Okay, that will make your code a lot easier, right? Some people use a very lengthy uh, data frame, the object name. Then, because this thing will have to type in repeatedly into your code, right? The complexity of your code would like increase. Would add unnecessary complexity into your code, right? So try to keep the object name as simple as possible, right? So I read the data in, and this data is called D, right? And let's take a look at its columns, right? It actually has a lot of data column. The case one is called Digital Detective. So it's about the vehicle stolen event records in Chicago City. Okay? Car stolen events, right? In Chicago City. So because it's car stolen event, so it has an ID, right? Event ID, and then the date and time the crime occurred. Okay, the day and time actually. This column has day and time, and then the location description. Okay, and whether the crime has solved. I mean whether the car thief was arrested. Okay, it's a true and false. Okay, um, there are a lot more uh, columns here, but they are not used in this case. Okay, what we use in this case is actually three columns. First, date. Okay, the second, location. The third, whether that event is arrested. Okay, in this exercise, we only use like three columns. The rest of the column is not used, so don't worry about them. Okay. So as you can see that we're reading the data, and there are some very simple questions. How many rows, how many columns do we have, right? So how many rows do we have? We can use the number of row function, or actually in the RStudio you can read it directly from here, right? See, you have right? You have a data object called D, right? And it's the data frame of. So there are a lot of car stolen events, right? It's like 191,000 car stolen event. Okay, so in business data, you tend to have like hundreds of thousands of records, right? And every record represent what? In the beginning of a class, I say that when we do analysis, right, we always interest in a subject, right? So this subject in this data set is car stolen event, right? And what we are going to investigate is the day and time, right? As you can see that this is the day and time, okay? And then the location, it happened in street. It happened in street, and you can see that some happened in residential yard, okay? Okay? And then arrest is the true false column, right? It could be false, which means that the case is not solved, right? The thief is not arrested, okay? So these are the three columns that we want to handle in this case, okay? So if you were the law enforcement department, if you are a police station, knowing the time and place a crime would occur is important, right? Okay? This type of data is called temporal spatial data. It's time and place, right? So you know the event that happened, time and place of the event happening. So in this exercise, we would like to teach you how to deal with time data, because time and day is actually very troublesome. Right? Okay, it's not easy to handle time and date, right? So we'll teach you how to handle time and date, and how to do some data processing, so that we can extract useful managerial implication from the time and date data, right? That is the purpose of this exercise. Okay? Got me? Okay, so actually in the uh, in this YouTube playlist, I will give you some more instruction about how to do the notebook. Okay, so to watch the playlist first before you doing that. Okay, let's go back to the notebook. Take a closer look at it. It's here, and now talking about time and date. As you can see that in the raw data, in the original data, the time and date is recorded in this format. Okay. Now you can see that no, if you simply by looking at into this format, you cannot even tell uh, this is December 31 in 2012 something. You need to guess, right? Okay. Now I told you that time and day is very troublesome in programming because of two things, right? First of all, time in its nature, it's a timeline, right? So it's like kind of like a linear, continuous scale. Time is a dimension, right? So it's a linear, continuous dimension by its nature, right? But the trouble is like in human society, right? we don't do it that way, right? We divide it by month, and the length of months are different, right? Sometimes you have 31, sometimes you have 30, sometimes you have 28 and 29, right? Okay, so in human society, we divide 7 days into a week, right? We divide like it's not that like a real number, right? It's like human convention impose a lot of conventional rule when we refer to time, right? So and that would make computer very confused, right? Okay, in computer, time should be treated as a linear, continuous real number, right? But the human society use different ways of recurring time, right? That's the first thing, right? The second thing is that different people use a different format when they are doing time, right? Sometimes they will write year in the beginning. Sometimes they will write year in the back, right? Sometimes they will use 4 digit. Sometimes they will use 2 digit, right? Some people will say the months by digit. Some people would prefer to use January, February, and sometimes use their abbreviation, right? And sometimes they'll write it in uppercase, sometimes they'll write it in lowercase, right? There so many different combination of recurring time, okay? So it will make computer very confused, right? So um, so in order to make time and date calculable within computer, we need to do some conversion, okay? So in R, the conversion command is like this. So see if we print out the raw data, right? The data in this column, you can see that this column they are basically characters, right? They are just characters. They are not time. They are not of the time. So and it's in this format, right? So as I explained here, if you want to convert the day and time recorded in as a character string into a standardized time, international standardized time and day format, this POSIT is actually the international standard in recording time, okay? So before you can process time within the computer, you need to convert the character string into international standard digital time. You can think it that way, right? You need to convert it into a time international standard time format, okay? And to do that, you can use this for time, okay? Now, in this function, in addition to give it the character string, right? This is the vector of character string, right? You also need to give it the format, okay? You need to tell because it can be, I told you, right? The format can be changed a lot, right? So there's a code table, okay? For example, this is for months, right? In digit. Months and digit is coded as %m. Year of 2 digit is % lowercase y. % uppercase y is for 4-digit year, okay? And this is for day. And there's a code for hour, for minutes, right? Things like that, okay? So H is for hour and M is for minute, right? So you need to tell this function in what format this character are recorded, okay? So with these two information, it can convert this day and time in character string format into international standardized time format. Here I call it TS for timestamp for short. It's like every event has a timestamp, right? Including the day and time. So this timestamp, after I execute this function, I will have a timestamp vector. As we can see here, in the beginning, I only had this D data frame, right? And after I do this, okay, you can see that it will take some time, and there will be a new data object called TS. And this vector is a POSIT. As I told you that this is the international timestamp data type, okay? International standardized timestamp data type. And actually you can see that its length is exactly the same as the data frame D, right? Okay. So it virtually converts this character string into an internationalized standard time. So before you can actually use it, okay. Now, let's see, where is the? Okay, so in order to convert the string into POSIT, you use this command, right? Now, in order to convert the time back to whatever we want, right? Sometimes we need to convert the TS back to like weekday, back to hour, back to minutes, right? So if we want to extract the month of the date, we use the same coding table, okay? %B represent the month, right? %W represent the weekday 0 to 6. You see that? Okay. So in order to convert that the digital time, right, back to day, months, weekday, hour, minute, we will use this format function. Okay. So day and time needs some conversion, and that's you will get used to it when you start doing the real example. So see, so right now we have this TS, right? So if I want to see that, so I can do a lot of things, right? First thing I want to do is like, if I do a histogram on TS, okay, and I say by year. See that? Because this TS is actually a digital time, right? Okay? So you can treat it as a real number. It's no longer the human society, very choppy, very tricky things, right? You can treat it like a numeric, okay? So you can treat TS as a numeric. So you can see its distribution, isn't it? Right? Okay? So as we can see in this code chunk, you can plot the event counts by year, right? And this the event count in quarter. Okay? If you want, you can actually do the event count by month, simply by put this into month. Okay? As I told you that the part here and also all of these, the function code looks a little bit complicated, right? But it's just to make the just to make the histogram better looking. Okay, so if you do not care about the looks, right? You only want to see the data. It actually, the function code is as simple as like this. Okay, so don't worry. In the beginning, don't worry about the things, right? The thing here and actually also the thing here. They just to make it a better looking, right? We do not have time to cover that, right? So you can like play with them. I'll let you play with them by yourself, okay? Now, so how is the data useful, right? So the first thing is if I, as I told you that I can format, if I do that, if I format this TS into weekday, right? Remember that? So I told you that percent %W is converted into weekday, right? 0 to 6. So if I want to know that see, you will convert the timestamp into the weekday, right? 0 to 6. So if I convert and then put the conversion into a table, right? What do I have? So what does this mean? It means that in Sunday I have so many events. In Monday I have so many events. See that? So within the week, which weekday has the largest number of event? Friday, right? It's Friday. It's easy. Okay. So see, that's how we use the time and day data, right? Before using it, we need to like convert it into a digital time, a digital time format, right? And then before we're using it, we need to convert it back to a thing that we want to use, right? So if I try to do it in hour, what does it mean? What do you see in this chart? Let's make it easier. Let's see it here. See, I do a table, right? And here I format the timestamp to extract the hour, okay? And then I do a table on the hour and I put it on the bar chart, okay? So as you can see that this is the 24 hours, the number of events, right? Total number of events in 24 hours, isn't it? And then, as I told you, right, I actually can like put the weekday and hour, right, into right, into within the table I can actually put two vector, right? If I put two vector, I will have a two-dimensional table, right? So this is the 724, right? The number of car stolen event in 2074. You see that? Okay. But actually, it's very difficult to look into the raw data directly, right? So in this code chunk, I actually below this table, I add a few lines of code to make it. This is what we call like heat map, right? It simply converts numeric into color, right? So the green color is the low number and the red color is the high number, right? So the within the 24/7, what is the hour that has the largest number of car stolen event? Can you tell? Which one?
The lowest car person, we look at
on Friday, right?
Yeah.
About 10 o'clock.
Yeah, I was question. What is day one is always Monday and 7 is a Sunday.
It actually depends on the code that you use, right? If you use a %u, as you can see here, it's 1 to 7, right?
Yeah.
From Monday to, and if you use %w, see it's 0 to 6. So
And then 0 is then
0 is the Sunday.
Sunday. Okay.
Yeah, 0 is the Sunday. So see, I told you, right? People kind of like recurring time in different ways, right? So okay, so this is how it is, right? Basically, you're still using table, tier, prime, that type of thing to do the count, right? But this in this notebook we are dealing with time and date. There are some spatial technique that we need to learn before we can deal with time and date, right? Don't worry about the visualization things yet. Later on, we will teach you how to do that in our class later. So don't worry about this thing yet. Okay. Now, so at the back of the this notebook, there's a thing called Ninja's Dojo, right? So which means that this is not your assignment. Okay. I just want to show you in Ninja's Dojo. I write the code for you already. So as you can see that it is a very long, very lengthy data processing pipe, right? On the top of the pipe, that's the data, right? So I just insert the data, and I will get this chart as the output. Okay. Take a closer look at this chart. The title is Vehicle Crime in a Week, right? And this column is arrested rate. Okay, and this column is number of event. Okay, and as you can see that this is different location, right? Car stolen location, street, parking lot, gas station, driveway, and alley. Okay, as you can see that the pattern, this is a 24/7, right? 24/7 heat map. So on street you will see a pattern is like this. Cars stolen on the street, they are mostly happen in the evening, right? And around midnight. Okay? But cars stolen in the parking lot are different, right? Most of the car lost in the parking lot, they happen in, right? In the afternoon, isn't it? Right? So so you can see that in different location, the car stolen event has a different distribution in time, right? Using a data language, we can say that in different location, we see a different distribution of car stolen event in time, right? Okay. So, well, as a beginner, it's very difficult for you to like write code to do things like that, right? As I told you that in this dojo, I want to show you the potential, right? Okay, in R. So you can actually do a very, very sophisticated analysis on the data. So if you are law enforcement department, right, in Chicago, now looking at this chart, what can you do? If you are law enforcement department, right, how can you make use of this chart?
With this chart, we know the higher probability of cars being stolen during a particular day and time.
Right, you know that.
So the
For what purpose?
so that you can make more arrests.
So you can make more
Alright.
arrest, right? Uh, so, so how can the chart help you? Actually, it will help you to do your manpower allocation, right? You know when to send your team, when to dispatch your team to where, isn't it? Right? Okay. So and you also know that the arrest rate, right? Okay. So actually, if you are a motor thief, how can the chart help you? If you were a motor thief, right? How can the chart help you?
I know what the arrest rate is. So
Yeah, you want to avoid high arresting rate, right? You want to avoid that. Okay. So that's when we put data to use, right? By looking at the distribution of event in time and space, then so we can make managerial adjustment for better performance, isn't it? Right? That's how we put data to managerial use. Okay? We don't need to learn some modeling, some prediction, some optimization, some simulation yet. Okay? Simply by processing the data, simply by using table and apply, simply by counting, proportioning, and comparing, we can do a lot of things already. Okay? Get it? You get the point, right? So all of this assignment, they are designing in this way. Okay? Now let's take a look at the second one. Okay? The second notebook is about the stock market. Okay? So here we want to learn a few things. We want to learn uh, stock market is so-called time series data, right? It's time series, right? And in the stock market, there are a lot of stocks, right? So you need to do some repeated computation, right? If you want to do the same function on 10 stock now, and you don't write the same code 10 times, right? So how can we do the repetition when you deal with the uh, similar data structure? You want to do this same operation on the same data structure again and again, then we will have some way to help you do that, right? Okay, and that's the purpose of this notebook. First of all, we want to teach you how to handle time series data, right? Second things, we use line plot as we have demonstrated to you, right? To visualize sequential data so you can see the trend, right? If you want to see the trend, you cannot look into the data directly. It's very difficult. So you can use the line plot to see the trend. And most of the questions within this notebook, they involve you to plot the data in line plot. Sometimes you plot multiple stock in the same plot, okay? And then compare their trend. See? Okay? So that's all about this notebook, okay? They teach you how to handle time series data, plot them in line plot, and draw multiple lines in the same plot. And maybe you can add some assisting line for comparison, right? Okay. And we also teach you a way to do repeat computation, right? On vector or list, okay? So if you go to data cam, go to RStudio, you will see. Now in the data folder, you will see a this is the stock price. Okay, this is the stock price for Boeing. As you can see that they are date, and there's the stock price. There's a date and there's a stock price. Okay, so we need to, before doing that, we need to read the data into our environment, right? So you can like kind of like read the data into the environment. Okay, so but if we do that, if we do this command, do this line of code, it will actually read IBM stock price into IBM, right? You'll see IBM here. You will see it. So every stock, every company, I should say that, every label has a data structure, right? But if you want to do some repetition computation, it will be difficult because you will need to write a line of code for each of this stock, right? So in order to do some repeat calculation conveniently, a better way is to keep all of the stock in a list, okay? That's how you use a list, okay? Now we put all of this symbol within a list. So the list is actually a list of 5, okay? And every element of a list is the data frame, right? See that? And every data frame has a date and has a stock price column, right? Actually, you can see that also by click here. So you can see that under L, there are 5 data frame, okay? And within each data frame, there are 2 columns, right? The first column is, as you can see, that's character, right? So later on, we need to convert it into a date, a digital date, okay? Before we can actually plot it or before we can actually calculate it, okay? And that can you do 5 times, right? I need to do 5 times, okay? So in the if we put that in a list, now we can do the conversion in this way. See, here it's day is character, right? Day is character. Now I want to convert this column into a date data type, right? Okay, so I'll do it like this. As I told you, right? I call as date because there's no time, right? It's only date. And besides the character string, I also need to tell, I also need to specify the format, right? Okay. So after I do this, look at here, right? Right now it's character, right? So I do it. As you can see that all of them turn into date, right? Okay. See that? Okay. And then you can like do because it's already date, so you can do a lot of like calculation or plotting, something like that, right? For example, if I want to plot the stock price of IBM, right? I can do a plot, okay? And I do L, and here, IBM, right? Now, because this data frame is within a list, right? So we want the IBM data frame, okay? And then I want its date as the X, right? And I want its see, now you can see the, in 1980 there's a clash, right? There's a market crash, but this is not what we want, right? we sometimes want to have, I already told you, right? If I want to have a line plot, I simply say add an argument called type equal to L, right? And that would do it, right? So this is the IBM stock plot, okay? Actually, within the same plot, I can do, if I want to do like G, and I execute this line, it will plot a line of GE, right? But how can I compare them, right? If I want to like compare the stock price trend, what can I do that? Well, the things to do that is like you will have to the first plot is for IBM, right? And the second plot is for GE. And you do not use plot, otherwise you make a new plot, right? So you use line, and then you specify another color, right? It's color equal to like blue, okay? See? Then you'll see the two plot together, right? See that? So in this exercise, it will lead you through how to use line plot to compare the trend of time series, right? Okay. So because we are running out of time, okay, so I cannot show you too much detail. So what I can do is actually I have already upload the reference answer of all of this assignment for you, okay? Which means that there are some plotting syntax which is too cumbersome to cover line by line in the class loop, right? So I actually give you the reference answer, right? If you go to if you go here, you will see sorry. Actually, if you unzip the file, you will see a AX3EX folder, and below the folder you will have you basically will have the it will teach you how to do the visualizations in the code already. Okay, see that? So the syntax is actually like very easy to understand if you look into the code and the chart by yourself, right? So rather than like teach you in the classroom, I'll let you do the charting by yourself. Okay? Now the third notebook that we want to cover this week is called, we have 5 minutes left. My God. Okay. And actually, all of the three notebooks, I already have all of the answer already provided for you. Okay, it's in here, right, in this zip file. So it's about the actually it's about the census in the United States. Okay, and The only thing I need to you need to know is that in this data set, we are having a census data, okay? So this census data, so every data represent a citizen, okay? Uh, so and within this data, there are two um, spatial column. Here is the metro area code, and here is the country of birth code. As you can see that this is a code inside here, right? The code is a digital number, so by the code itself, we cannot tell which country, which metro area that that citizen belong to, right? So so it actually so within the data folder, it actually has a metro area code and actually has a country code mapping table. Okay, so after we read in these two things, this is the country code mapping table. Okay, and this one is the metro area code mapping table. Okay, so they map to the metro area code column. As you can see that there's a number here, right? So you need to look up this number in the metro area, right? So to determine what is country code 57, right? For example, if you want to find out what is country code 57, you need to look into this table. 57 is the United States. You can see that? So it involved the merging of data frames, okay? You learned that, right, in your data camp exercise. You might still remember if you do that. Maybe not. Okay, forget it.
Join into vector?
Yeah, not join into vector, join into data frame.
Yes.
Now we are talking about joining these two data frame together, right? Here I only have the country code. Now I want to use this table to convert the country code into a country name. Isn't it? Right? So this is what we mean by merging data table. Okay. Merging data table is not very difficult, right? Just read in the data and just use the merge function to do the merging, right? Okay. With this function, you want to kind of merge two data frame, right? D and metro. D is this one, and metro is this one, right? And and within the D data frame, there's a column called data area, metro area code, right? And metro, there's a code. So you want to match these two columns and pull the metro area into data frame D. As you can see that here, we only have the metro code. We do not have a metro area, right? So after merge, you will see a new column in D, and the name of the new column will be called metro area. Let me execute it first. See that the last column is industry, right? So after I merge D with metro, I will have a new column called metro area, right? Okay. So how this metro area code is produced? It actually look up the metro area code, right, into this column, and then pull the name to here. The same thing apply to country code, okay? So in this assignment, it teaches you how to do data frame combination. Okay, it's the one thing that we want to learn in this table. And there, the second thing that we need to know. Sometimes when you do a data merging, you will find that the data, when you look up the data, sometimes you cannot look it up, right? It's not there, right? There is a country code, maybe it's a typo or something. So you cannot determine which country it is, right? So the value in that position will become not a variable, right? Especially when you are doing census, some subject would like they will do a typo, and sometimes they will just miss the questionnaire items, right? So when you are collecting questionnaire, it's a nature that there will be some NA within the data, right? Now NA, whether it's not applicable or not available, okay, will cause a lot of problem when we do data processing, right? In R, for example, if I want to do sometimes they are when they are NA within the data, and you apply a R function on that data. Let's check it. Okay. So you can see that they are in employee status. There are a lot of NA, right? Industry, a lot of NA. Education, there are a lot of NA, right? Marriage, there are a lot of NA. Metro area code, there are a lot of NA, isn't it? Right? So if you try to apply the regular sum, mean, summary, that type of thing to a vector that contain a NA, the result would be NA. Okay. I mean, if you try to like if I want to count the see, I see that there are some. No, let's. Metro area code 10420. So when you do this mathematical operation, it actually will produce a vector with NA inside, right? Because some of the position in this vector, they are not available, right? And it will result in that the outcome will always be NA, right? So one way to handle NA is to add NARM equal to true. Add this argument. It means that remove all of the NA before you do the summation, or before you do the right? See, you can do the count. Okay, it means that before I do the whether do the mean or do the sum, I remove NA before I do the calculation. Okay, so this is the proportion of metro area code. Okay, and this is the number of metro area code 10420. See that? So in this notebook, it majorly teach two things. Okay, first thing is the merging of table, merging of data frame. I should say that, and the second thing is the handling of NA. Okay, again, I already provide you first of all, a YouTube playlist, right? So you can see the playlist. And second, I will already give you the reference answer, right? For all of the questions inside this assignment. Okay? So get together, and today we do not have personal assignment. We only have a team assignment. And you want to get together and finish the 3 notebook and then upload it uh, into the uh, into the into this folder. Okay. Okay. Here, every group has a. We do not have 4 and 5, right? Okay. So I can actually remove them. Okay. Question? Okay, so we are ready to like put some real data to some managerial usage, right? So do it, and we will kind of like review the this. We will start with reviewing this these 3 uh, data cases next week. Okay. Okay. If no question, we will stop here today. Okay. See you next week.